Hello class, this is a video tutorial on the relationship of the derivative to increasing, decreasing, and or stationary points of a function. From our understanding of linear functions and gradients, we can establish a relationship between derivatives and the nature of a curve. So we know from linear functions, if we have a gradient that is, well, this is the rise and the run, we can see here that we have a positive gradient, so m is greater than 0, and we know that this function is increasing. If m is less than 0, so the gradient is less than 0, the function is decreasing. And if the gradient m is, well, stationary, the line is flat, and it is not moving, it is stationary. We're going to combine this with our idea of functions and its derivatives. Given a function f of x, its derivative measures the gradient of a tangent at a point. So if we have some function, this green one here, if we take the derivative, if we substituted the value of a into the derivative, what's really going on is we are taking a tangent at the point a, and we are measuring the rise and the run of that point, okay, which gives us the value of m at the point A. A more numerical example here. If we have some function and we derive it, if we wanted the gradient of the tangent at this point, x equals -2, we merely substitute -2 into the derivative function, and the result that it gives us, so this 20 is actually the gradient of this line here. So from this example, we can see the gradient of the tangent at the point x equals a is greater than 0. So this tangent has a positive gradient. So m is greater than 0 of this tangent that I just drew here. This one here. But also, we know that f prime of that point measures the tangent. Okay, so we can see that by measuring the tangent using the derivative, we can determine that f of x is increasing at x is equal to a. We can extend this further and see that if f prime of a is greater than 0, f of x is increasing at x equals a. F prime of a is equal to 0. F of x is stationary at x equals a. And f prime of a is less than 0. F of x is decreasing at x equals a. So let's do a few examples to really get our understanding going. So let's determine where along this curve the function is increasing, decreasing, or stationary. So let's get to it. Let's just go from left to right. Now how we do it is this point here. We just draw a tangent passing through that point, and we notice that that tangent has a positive gradient. And a positive gradient means it is increasing. So at this point here, at x equals a, it is increasing. Let's determine this point here. If we draw a tangent at this point, at x equals b, well, it's flat line, so that is a stationary point. So stationary at x is equal to b. Let's find the next one. This point here, c, let's draw a tangent at this point. Looks kind of like this. That tangent has a negative gradient. So if it has a negative gradient, then that must mean it is decreasing. So at x is equal to c. Next one, this point D. Well, if we draw a tangent at this point, it is exactly flat. That is a 0 gradient. So that is a stationary point. So that is D is also stationary. point E here. Draw a tangent at that point. Once again, it's flat. It has a 0 gradient, so it is a stationary point. We have one last point here, F. If you draw a tangent at that point, you can see that this tangent has a negative gradient. So F is decreasing. Here we go. Determine whether the function is increasing or decreasing or stationary at the given values. So here we have our function. In order to continue, we need our derivative function. So f prime of x is equal to 2x minus 4. Now, to determine the nature at this point, we merely substitute x equals 0 into our function. So f prime of 0 is equal to 2 times 0 minus 4. That is negative 4. And that is less than 0. So f of 0 is decreasing. Let's see this again. We already have our function. So all we need to do now is f prime of this value 2. This will give us 2 times 2 minus 4. And that is equal to 0. Well, f prime of 2 is equal to 0. Well, then we can say f of 2 is, so now remember, if f prime is equal to 0, here we go, then that point is stationary. So f of 2 is, stationary. Let's do this 2 more times. So f prime of 4 is equal to 2 times 4 minus 4. That is 8. Take away 4 is equal to 4. And 4 is greater than 0. So then we can say f of 4 is increasing. One last time. F prime of 6 is equal to 2 times 6 minus 4. That's 12 take away 4, which is 8. And that is greater than 0. And if it's greater than 0, well, f of 6 is also increasing. So I hope that gave you an insight into the relationship between derivatives as well as the nature of the point and their gradients. Hope to see you in the next video. Best of luck.